So the first step is to write your set of parametric equations, one for x and one for y. So think of it as slope-intercept form, where your starting number as your order pair, and the slope is your horizontal and vertical component, your delta x and your delta y. So for your parametric equations, you would have x of s, and you can use any variable. You don't have to use s. You can use a different variable. So that would be 2 plus 1s, and then y of s starts at 5 plus 3s. So that's my equations, and I'm going to use that to determine if this point is on the path. So in order to determine that, I'm going to take this 8 and substitute it in for x of s. So I'll have 8 equals 2 plus 1s. And then we have 23 equals 5 plus 3s. Go ahead and solve both of these equations for s. And what did you get for the first equation? What did you get? You should get 6 because you're subtracting 2 and dividing by 1. And for my second equation, you should also get 6 because you're subtracting 5. 23 minus 5 is 18, and 18 divided by 3 is 6. So because we have the same number, what does that mean about this point? It is on the path. So yes, the point 823 is on path. Okay, so it's a yes. If it's different, then we say no. But because we have the same s value, that point is on the path. For number 2, we talked about scalar versus vector quantities. A scalar quantity does not have direction, and a vector quantity does. So for part A, it says you're suspending a 5-pound pitcher on the wall with a string. So what do you think? What would that be? Would that be a scalar or a vector quantity? Vector because of gravity. So this would be a vector quantity. Driving 60 miles per hour on the highway. Yep, that would be a scalar quantity. Good. Okay, so we're going to start 9.5. So quick announcement about homework 19. Homework 19, the due date has been pushed to Tuesday because the back side. So the back of homework 19, we're not going to cover until we get to the very end. So what I'm going to do is, there's only one more homework assignment, homework 20. I'm going to pass that out today. You'll be able to finish all of homework 20 today. That's very simple. But homework 19 has some kind of complicated word problems that we're not going to start till tomorrow. So you won't be able to do that and have those turned in by Friday. So homework 19 is now pushed to Tuesday. So you can go ahead and write that on your homework 19. Homework 19 and 20 will both be due Tuesday. And I think Tuesday is the 3rd. Yeah, so they're both due on the 3rd. All right, so really quickly, take out your notes. I think we're on page 10. We're in the back. So we have another formula that we're going to cover. And it's called dot product. It's a pretty simple formula. This is your formula for the dot product. Multiplying two vectors together. So that's not the same as a scalar. As multiplying by scalar. So we're actually taking two vectors and multiplying them together to find the dot product. So what we have here, the formula says if vector v is x1 and y1, and vector w is x2 and y2. And this should be at the top of page 10, this formula. Then to find the dot product, we're going to multiply our x's together, multiply our y's together, and then add those. So for example, if I'm going to call this one my x1, y1, and the second one is x2, y2. So let's multiply them together. So I would have 3 times negative 2 plus 5 times 4. That's how you find your dot product. Multiply your x's, multiply your y's, and then add those together. So that would simply be negative 6 plus 20, which would be 14. Go ahead and do example 2 by yourself. Find the dot product. So for example 2, when we label that, we have our x1 and our y1 and our x2 and our y2. So we multiply it out. We have 3 times 5 plus 4 times negative 1, which is 15 plus negative 4. So who got 11 for their second answer? All right, good. So now let's figure out how to find the angle between two vectors. So if we have two vectors, the reason why dot product is important is because we have to know the dot product to find the angle between two vectors. So in order to find the angle between two vectors, we're going to take the dot product, that's in our numerator. So first we have to find the dot product. And then we need to find the magnitude of both. We're going to multiply the magnitudes together. Okay, so for example 1, I have vector v and vector w, and I want to find the angle between those two vectors. So to do that, the cosine of theta is going to equal our dot product, which again, to find our dot product, we multiply our x's, so that would be 3 times negative 2 plus 5 times 4. And then we're going to find the magnitude. So you do need to know how to find the magnitude. So to find the magnitude of vector v, it's the square root of each component squared. So that would be 3 squared plus 5 squared. And then we're multiplying that by the magnitude of vector w, which would be negative 2 squared plus 4 squared. So we actually did this example. So what is this? 14. Negative 6 plus 20 is 14. All right, so what do you get here? What's 3 squared plus 5 squared? 34. And no calculator. That's impressive. And then for my second magnitude, we have 2 squared plus 4 squared. 2 squared 4. 4 plus 16, 20. Okay. All right. So we're multiplying these together. So what is 34? You can multiply 2 square roots. So 34 times 20 is 680. So in your calculator, so we have the cosine of theta equals 14 divided by the square root of 680. And when you type this in your calculator, theta equals the inverse cosine of 14 divided by the square root of 680. Go ahead and type that in and see what you get for your angle. So when you type that in, make sure you're getting the right answer. I got 57.529 degrees for my angle. Who got that for their angle? All right, try to do example 2 by yourself. Find the angle between those two vectors. Okay, here I come. Oh, thank you. Good looking out, Michaela. Did you get it the second time? You got it? Okay. Okay. So who got 90 as their angle? Which, this is a special type of, because it's a right angle. So there's actually a special word for that. Now, anytime you get 0 as your dot product, you can really stop there. Because 0 divided by anything is 0, right? So it doesn't really matter what I get in my denominator if my numerator is 0. Yes, Andrew?
You wouldn't do 90 comma 270?
I wouldn't do 90 divided by 270.
I said comma 270, like it could be both methods, or it can only be 90.
Is 90. So we'll talk about why that is. Okay, so let's go ahead and look at this definition. It's at the bottom. And what this says is anytime you have your dot product is 0. Okay, there we go. So anytime we have a dot product of 0, the vectors are orthogonal, which is a fancy word, but it just means that they're perpendicular. Which means that they form a 90-degree angle. A right angle. So that's what that means when you see that. So if you see that the dot product is 0, then the angle is going to be 90. You can actually stop right there. You don't even need to finish the formula. So a dot product of 0 means that you have an angle, a right angle. So the formula for work says work equals force times your displacement, force times distance times the cosine of your angle. So go ahead and read that first question on page 11 and see if you can figure out that we're looking for 3 numbers. So work equals, let me write it up here again. So we have our force, we have our angle, and we know the distance. Those are your 3 numbers. So work is going to equal force times the distance times the cosine of your angle. Go ahead and type that in your calculator. And the unit of measure is joules. And joules is newtons. A joule is a newton times a meter. So joule equals 1 newton times a meter.